Hello student. Uh, Today we will discuss the unit 4, and in our previous class we have been started unit 4. Okay. Okay. In unit 4, 4 contain gear law of gearing, gears law of gearing, conjugate profile and graphic construction, involute and cycloid gear tooth profile, construction of involute profile, path of contact, arc of contact, contact ratio for involute and cycloidal tool profile, interference in involute gears. Critical number of teeth for interference-free motion, motion to control interference in involute gear. Okay, basically this unit is divided into two parts, gear and gear train. And जो अभी हमने आपको बताया, it is all the part of a gear. And now in a gear train consists of kinematics and dynamic analysis of simple gear train, compound gear train, reverted gear train, epicyclic with spur gear or bevel gear combination. Okay, in our previous class we have been discussed gear law of gearing, and today classes we discuss involute and cycloidal gear tooth profile. And it means our first topic is uh, forms of teeth. Okay. Okay. Basically, conjugate teeth are not in common use, and therefore in actual practice following are the two type of teeth commonly used. Okay, first one is the cycloidal teeth and another one is the involute teeth. Okay, अब हम सबसे हमें पता है कि दो टाइप के टीथ होते हैं, हमारे साइक्लोइडल और इन्वॉल्यूट। अब इन दोनों टीथ के बारे में हम पढ़ेंगे कि इनको बनाया कैसे जाता है। ओके, फर्स्टली in a involute teeth, cycloidal teeth. Okay, a cycloidal teeth is the curve traced by a point on the circumference of a circle which rolls without the slipping on a fixed straight line. Okay, when a circle rolls without slipping on the outside of a fixed circle, the curve traced by a point on the circumference of a circle is known as epicycloid. On the other hand, if a circle rolls without slipping on the inside of a fixed circle, then the curve traced by a point on the circumference of a circle is hypocycloid. ओके, बेसिकली साइक्लोइडल टीथ जो होते हैं बेसिकली मेड ऑफ अ टू कर्व. ओके, फर्स्ट कर्व इज द एपिसाइक्लॉइड एंड अनदर जो आपका कर्व बनाता है वो हाइपोसाइक्लॉइड बनाता है. ओके, तो बेसिकली ऐसे आपके ये अकॉर्डिंग टू द डेफिनेशन अ साइक्लोइडल इज द कर्व ट्रेस्ड बाय अ पॉइंट ऑन द सर्कल which rose without slipping on a fixed straight line. फिक्स स्ट्रेट लाइन के ऊपर किसी चीज सर्कल का स्लीपिंग सर्कल का स्लीपिंग होना विच रोल्स विदाउट स्लीपिंग ऑन अ फिक्स स्ट्रेट लाइन, then the then the teeth is formed is the a cycloidal teeth. Okay, and in this diagram we see that there is a pitch line which is straight line, a circle it rolls without slipping on this fixed straight line. Okay, so this circle is shown that, and dotted line the is the position of the circle when it is in motion. Okay, and when it is in rows. Okay, then there is a in a pitch line there is a two curve AP and BP. AP forms a face of the teeth and BP forms a फ्लैंक ऑफ द टीथ. ओके, एंड हमने इसमें कहा भी है कि जो हमारा कर्व इज ट्रेस बाय ए पॉइंट ऑन सर्कमफ्रेंस ऑफ ए सर्कल, यानी कि जो आपका when a circle without slipping on the outside of a fixed circle, the curve traced by a point on the circumference of a circle is called the epicycloid. This curve is epicycloid and this one is the hypocycloid. Okay, तो ये आपका हाइपोसाइक्लिक इस तरह आपका जनरेट होता है। जो इसमें हमारा जनरेट होता है ये सर्कल, ये आपका टीथ, वो अकॉर्डिंग टू द आपका जो आपका सर्कल है वो आपका एक फिक्स लाइन के अबाउट रोल्स करता है विदाउट स्लिपिंग। तो हमारा ये जनरेट होते हैं, इसमें दो कर्व जनरेट होते हैं, जो एपिसाइक्लॉइड और हाइपोसाइक्लॉइड, और वो जनरेट करते हैं फेस पार्ट और फ्लैंक पार्ट। ओके, in the figure the fixed point line of pitch line of a rack is shown when the circle C rolls without slipping above the pitch line. Then the point P on the circle trace epicycloid PA. ओके, दिस यानी कि जो आपके हमें पिच लाइन से ऊपर का पार्ट दिख रहा है, ऊपर का कर्व दिख रहा है, इट इज कॉल्ड द एपिसाइक्लॉइड विच इज द पीए। एंड जब आपका ये सर्कल रोल करता है तो हाइपोसाइक्लॉइड कब बनेगा? जब पिच सर्कल के नीचे वाला पार्ट, दैट इज पीबी। Okay, this is the and the epicycloid जो कर्व होता है, it represent the face of the cycloidal tooth profile. This one. Okay, and the circle D, this one, and the circle C is rolls without slipping on a fixed straight line, then formed a curve AP, which is the epicycloid, and forms a frame of a face of a tooth. Okay, and when the circle D it rolls without slipping on a fixed straight line, then the point P on the pitch circle D traces hypocycloid, which is the PB, and represents the flank of the cycloidal tooth. The tooth profile BPA, this one, BPA is the one side of the cycloidal rack tooth. Similarly, the two curve P dash A dash and P dash B dash forming the opposite side of the tooth profile are traced by the point P dash when the circles C and D are rolled in opposite direction. Okay, it is all about the cycloidal teeth. और जब हम बात करेंगे कि जब सिमिलर वे, जैसे जो आपका सेकंड डायग्राम हमारा बना हुआ है, इसमें क्या सर्कुलर टीथ का आपका कंस्ट्रक्ट करके दिखाया है। यदि सर्कल सी इज रोल्ड विदाउट द स्लिपिंग on the outside of the pitch circle and the point P on the circle traces a PA and which represents the face of the this one। और इसमें क्या है कि इसमें एक स्ट्रेट लाइन दिखा दी पिच, इसमें कर्व के फॉर्म में दिखाया, तो इसमें भी इसकी तरफ रोटेट करेगा तो दो पार्ट बन रहा है PA एंड PB। PA जनरेट द फेस ऑफ द साइक्लोइडल टूथ and it is the epicycloid and the PB is the hypocycloid and represent the flank of the tooth. Okay, and there is another thing is the when the two gear are meshing. Okay, when the two gears are meshing like that, just a minute. Okay, there are two gear matching cycloidal teeth आपके दिख रहे हैं, दो गियर इसमें मैश कर रहे हैं and a point on the circle D, जो सर्कल D है नीचे वाला, will trace the flank of the tooth T1 and when circle D rolls without slipping on the inside of the pitch circle of wheel 1 and face of the tooth T2 when the circle D rolls without slipping on the outside of the pitch circle of wheel 2. ओके, फेस कब बनेगा? जब इनसाइड द पिच सर्कल रोल करेगा और आउटसाइड द पिच सर्कल करेगा तो फ्लैंक आपका जनरेट होगा। सिमिलरली अ पॉइंट ऑन द सर्कल सी विल ट्रेस द फेस ऑफ टूथ T1 एंड फ्लैंक ऑफ द टूथ T2। ओके, जो आपका D है वो आपका फ्लैंक बनाएगा T1 का, और T2 का फेस बनाएगा, और जो C है वो T1 का फेस बनाएगा और T2 का फ्लैंक बनाएगा, जो कि हमें डायग्राम में दिख रहा है. Okay, there is two gears C and D which are mashing, and there is two pisc circle curve of first gear C, which is the wheel 1, and the gear D, which is the wheel 2. Uh, the rolling circle C and D have unequal diameter, but several wheels are interchangeable. They must have rolling circle of equal diameter. Okay, it is all about the cycloidal teeth. Okay, now we discuss the involute teeth. Okay, now then we discuss the difference between the cycloidal and involute. Okay, firstly in this diagram, this is the profile of the involute teeth. In this diagram, we see that this tooth is generated by only one curve. Okay, so it means involute. There is a definition of involute teeth. An involute of a circle is a plane curve generated by a point on a tangent which rolls on the circle without slipping, or by a point on a taut string which is unwrapped from a reel as shown in figure. Okay, involute जो है सर्कल, involute जो टीथ है और सर्कल का प्लेन कर्व जनरेटेड बाय अ पॉइंट ऑफ टैंजेंट. इसमें हमारी किसकी बात होती है? टैंजेंट की. विच रोल्स ऑन द सर्कल विदाउट स्लीपिंग, और बाय अ पॉइंट ऑन अ टॉट स्ट्रिंग विच इज अनरैप्ड. जैसे जो आपकी रील होती है इसमें धागा वहां लिपटा होता है, उसको हम क्या कहते हैं? उसको हम टॉट कहते हैं. उसको जब अनरैप्ड कर रहे हैं, वो आपका धागा निकल रहा है, उस चीज का इसमें कॉन्सेप्ट होता है. ठीक है. इन कनेक्शन विद टूथ इज बिल्ड द सर्कल इज नोन एज बेस सर्कल. द इन्वॉल्यूट इज ट्रेसेस एज फॉलोस. इसका हम डिस्कशन करते हैं कैसे इन्वॉल्यूट टीथ की प्रोफाइल हमारी बनती है. ओके, इट इज जनरेटेड ऑन द बेस सर्कल. Firstly, we draw the base circle. Okay, this is the base circle. Okay, firstly, A with the starting point. This is the A point. Okay, the base circle is divided into the equal number of part AP1, AP, P1, P2, P2, P3. This part is divided into equal part. This part. Okay, this is equal AP1, P1, P2, P2, P3. It is the equal part. इसको हमने डिवाइड कर दिया, यानी कि ये दिस इज द एंगल इज 90. 90 को हमने इक्वल पार्ट्स में डिवाइड कर दिया. ओके, 4 पार्ट्स में दिया हमें डिवाइड करना है, तो 90/4 क्योंकि उसने कहा हम एंगल बना लेंगे. अब नाउ फ्रॉम tangent at P1, P2 and P3 are drawn and the length of P1 A1. अब हर पॉइंट से हमने एक टेंजेंट ड्रॉ करा इस सर्किल पे, और जो लेंथ होगी इट इज इक्वल टू द AP1. जितनी AP1 की आपकी लेंथ है, उतनी लेंथ के बराबर हमने यहाँ से टेंजेंट ड्रॉ करा. AP1, ठीक है. एंड नेक्स्ट इज द AP2. AP2 के बराबर P2 से ड्रॉ करना है. Sorry, like that. It is this point is A1 and this is A2 and this is A3, and then A1, A2, A3 हम ज्वाइन कर देंगे, और ये जो बना है इट इज कॉल्ड द इन्वॉल्यूट कर्व A in R. ओके, दिस वन इज द इन्वॉल्यूट कर्व AR. ये आपका इन्वॉल्यूट टीथ हमारा बन गया है. ओके, यही हमने बताया है, let A be the starting point of the involute and this point is the A. Okay, and the base circuit divided into equal number part AP1, AP, P1, P2, P2, P3 and tangent P1, P2, P3 से हमने tangent draw करा है and P1 A1 is equal to the AP1 and P2 A2 is equal to the AP2 and P3 A3 is equal to the AP3 और जहाँ पे कटे A A1 A2 A3 को हमने meet कर दिया or obtain the involute curve AR. Okay, a little consideration we show that at an instant A3 the tangent A3 to the involute is perpendicular to P3 A3 and normal to the involute. Okay, it means normal at any point of an involute is a tangent to the circle. Okay, यानी किसी भी involute पे कोई भी एक normal किसी point के हमने normal draw करा, it is the tangent to the circle. Okay, and now is the diagram of the meshing of two gear like that. There is a let O1 and O2 with a fixed center. There is a O1 and O2 which are fixed center of the two base circle. Let the corresponding involute AB and A1 B1 is the contact at point Q. MQ and NQ are the normal to the involute at Q and are tangent to the base circle. Since the normal of an involute is given point is tangent drawn from that point to the base circle, therefore the common normal Mn at Q is also the common tangent to the base circle. Okay, we see that common normal Mn intersect the line of center O1 at 2 O2 at the fixed point that is called pitch point. Therefore, the involute T satisfies the fundamental condition of constant velocity ratio जिसको लॉ ऑफ गियरिंग में कहा था. Okay, it is all about the involute and the cycloidal teeth. Now we discuss the comparison between involute and cycloidal gear. It is very important from exam point of view. Okay, and write down that there is a advantage when there is a comparison between the involute and the cycloidal teeth. There is we write down the only advantage of involute gear and advantage of a cycloidal gear. Okay, no doubt advantage of involute here, it means the number one is the most important advantage of the involute gear is that the center distance for a pair of involute gears can be varied within limits without changing the velocity ratio. This is not true for cycloidal gears, okay, which require exact center distance to be maintained. Now, in involute gear, the pressure angle from the start of engagement of teeth to the end of the engagement is remains constant because there is only one curve. Okay, it is necessary for smooth running and less wear of gear. But in cycloidal teeth, the pressure angle is maximum at the beginning of engagement, reduce it to zero at pitch point and start decreasing and again maximum at the end of engagement. This result less smooth running of gears. Okay. Number third is the face and flank of the involute tooth are generated by a single curve, whereas in cycloidal gears, double curves that is epicycloid and hypocycloid are required for the face and flank respectively. Thus, the involute teeth are easy to manufacture than the cycloidal teeth. In involute system, basic rack has straight teeth and the same can be cut with simple tools. Okay, it is the advantages of involute gear. Now we discuss the advantages of cycloidal gear. Cycloidal gear, since the cycloidal teeth have wider flanks, therefore the cycloidal gears are stronger than the involute gear for the same pitch. Due to this reason, the cycloidal teeth are preferred especially for cast teeth. Number two is the In cycloidal gear, the contact takes place between a convex flank and concave surface, whereas in involute gear, the convex surface are in contact. This condition results in less wear of cycloidal gear as compared to involute gear. However, the difference in wear is negligible. Okay. Number three is in cycloidal gear, the interference does not occur at all. Therefore, there are advantages cycloidal gear, but they are overweight by the greater simplicity and flexibility of the involute gear. Okay, it is all about the comparison between involute and cycloidal gear. Okay, now, okay, now system of gear T, there are basically four there are four system of gear T that commonly used in practice. The 14.5 degree composite system, 14 and half, the 14.5 full depth involute system, 20-degree full depth involute system, and fourth is the 20-degree stub involute system. Okay, the 14 and half composite system is used for general purpose gear. It is stronger but has no interchangeability. Okay, the tooth profile of this system has cycloidal curve at the top and bottom and involute curve at the middle portion. The teeth are produced by the formed milling center cutters or hawks. The tooth profile of the 14.5 degree full depth involute system was developed for use with gear hawks or spur and the helical gear. The tooth profile of the 20-degree full depth involute system may be cut by hawks. The increase of the pressure angle 14 to 20 degree result in stronger tooth because of the tooth acting as a beam is wider at the base. The 20-degree stub involute has a strong tooth to take heavy loads. Okay, it's all about the system of gear teeth. Now, now we discuss the length of path of contact. Okay, there are basically two gear are matching. Consider first gear is the wheel and the another gear is the pinion. Okay, consider a pinion driving wheel. This diagram is this. Okay. Okay. Consider a pinion driving the for wheel as shown in figure. First one is the pinion. This one is the this one is the okay. And when the pinion rotates in clockwise direction, The contact between a pair of involute teeth begins at uh, begins at D begins at C, and this point is also K, P, S. Okay, begins at K on the flank near to base circle of pinion or outer end of tooth face on the wheel and ends at L. MN is and this is MN, M, N. MN is the common normal at the point of contact and the common tangent to the base circle. The point K is the intersection of the addendum circle of wheel and the common tangent. The point L is the intersection of pinion and the common tangent. Okay. K is the this is the addendum. First is the base circle, then pitch circle, then addendum circle. Okay. So it means K is the intersection of addendum circle of wheel and the common tangent, and the L is the intersection of the addendum circle of pinion and common tangent. Okay, now the length of path of contact is the length of common normal cut off by the addendum circle of wheel and the pinion. Thus, the length of path of contact is KL. Okay, and which is sum of the part of the path of contact is KP plus KL. KL equal to क्या लिख रहा है आपको? KL equal to KP plus PL. Okay, the part of the path of contact KP is known as path of approach, and the path of the path is contact PL is known as path of recesses. Okay, basically that when the two gear are meshing, so when the start of engagement to the pitch point curve is called the and the path is called the path of approach, and the from the pitch point to the end of the engagement is called the path of recesses. Okay, so we do the this derivation. So firstly we note down the notation, the O1 and this is the O2. Okay, let RA equal to O1L, that is radius of addendum circle of pinion. Okay, capital RA, radius of addendum circle of wheel. R equal to small r equal to O1P, R equal to O1P radius of pitch circle of pinion capital R equal to O2P equal to radius of pitch circle of wheel. Okay. According to the diagram, radius of base circle of pinion, that is O1m equal to O1p cos phi. Okay, that is O1p is the R cos phi. And radius of base circle of wheel, that is O2n equal to O2p cos phi, that is capital R cos phi. Okay. Now from right angle triangle O2KN, O2KN, there is KN. राइट एंगल ट्रायंगल में हम क्या लगा सकते हैं? पाइथागोरस लगा सकते हैं. तो पाइथागोरस इक्वल टू हाइपोटेनस स्क्वायर इक्वल टू परपेंडिकुलर स्क्वायर प्लस बेस स्क्वायर. तो KN हमको निकालना है यहाँ पे. एंड फॉर राइट एंगल ट्रायंगल O2KN, O2KN, तो KN is the base. So base equal to hypotenuse square minus perpendicular square, that is O2k square minus O2n square. Okay, so Kn equal to Ra square minus R square cos square phi. Okay, and Pn equal to O2p sin phi equal to R sin phi. So length of path of approach Kp equal to Kn minus Pn, that is R a square minus R square cos square phi का under root minus K R sin phi, that is equation number 1. Now similarly for triangle, right angle triangle O1ml, ml equal to under root O1l square minus K O1m square equal to R a square minus R square cos square phi, and MP equal to O1p sin phi, that is R sin phi. Okay, so length of path of recesses, that is PL equal to ML minus K, MP equal to RA square minus R square cos square phi minus K R sin phi. Okay, that is equation number 2. So, so length of path of contact. So length of path of contact, it means sum of the path of approach and path of recesses. It means KL equal to KP plus PL equal to RA square minus R square cos square phi plus RA square R square cos square phi minus sin phi कॉमन ले लिया R plus R sin phi. That is the formula of path of contact. Okay, it is the formula of path of contact, that is RA square minus R square cos square phi plus RA square minus R square cos square phi minus R plus R sin phi, where RA equal to the radius of the addendum of the wheel, capital R showing the wheel and small r showing the pinion. Okay, now this is the length of path of contact. Now we discuss the length of arc of contact. Okay, and the arc of contact is the path traced by a point on the pitch circle from the beginning to the end of engagement of a given pair of teeth. Okay, in this diagram, the arc of contact is EPF or GPH, and the arc of contact is also divided into two parts. First one is the arc of approach and another is the arc of recesses. जैसे कि हमारा अभी लेंथ ऑफ पाथ ऑफ कॉन्टेक्ट में पड़ा, सेम इसमें भी यही है. ओके, तो आपका आर्क ऑफ कांटेक्ट का फॉर्मूला क्या होता है? आर्क ऑफ कांटेक्ट का फॉर्मूला होता है लेंथ ऑफ पाथ ऑफ कांटेक्ट अपॉन cos phi. तो आर्क ऑफ अप्रोच अपॉन cos phi प्लस आर्क ऑफ रिसेसिस अपॉन cos phi, लेंथ ऑफ आर्क ऑफ कांटेक्ट का जो हमने पाथ ऑफ कांटेक्ट अपॉन cos phi, तो हमने kp प्लस cos phi अपॉन cos phi दिस. ओके, इट इज द length of arc of contact. Now we discuss the contact ratio or number of teeth in contact. Okay, it is very important. The contact ratio or the number of pair of a teeth in contact is defined as the ratio of the length of the arc to contact to the circular pitch. Okay, so क्या हमेशा ये आपका whole number होगा. Okay, so contact ratio is the length of arc of contact divided by PC. PC is the circular pitch, which is the pi into m. Okay, m equal to the module. It is the formula of the um, contact ratio. Now we take an example of the regarding a numerical on basis of the path of contact. Okay. Okay. Okay, the number of teeth on each of the two equal gear teeth in meshes are 40. दोनों में सेम है, यानी कि कैपिटल टी और स्मॉल टी इज द सेम जो कि मैच कर रहे हैं. इट इज द 40 गिवन आपको डाटा हमें दे रखा है. 40. The tooth have 20-degree involute profile and module is 20-degree involute profile यानी कि phi equal to 20 degree and module यानी कि that is am equal to 6 mm. Arc of contact is 1.75 times the circular pitch. Arc of contact equal to 1.75 pc. Find the addendum. Addendum हमको निकालना है. अडेंडम हमको निकालना है. ओके, सॉल्व करते हैं. तो सबसे पहले PC इक्वल टू सर्कुलर पिच इक्वल टू पाई इंटू एम. पाई हमें पता है, एम हमारा 6 है, मल्टीप्लाई करी तो 18.85 mm. नाउ 18.85 mm. Okay, and length of arc of contact आपका क्या है 1.75 PC क्वेश्चन में गिवन है. तो 1.75 into 18.85 that is 33 mm. Now लेंथ ऑफ हमें पता है क्या, अभी हमने पढ़ा था लेंथ ऑफ आर्क ऑफ कॉन्टैक्ट इक्वल टू लेंथ ऑफ path of contact divided by cos phi. Okay, so length of path of contact आपका क्या हो गया, length of path of contact equal to length of arc of contact into cos phi. Okay, तो length of arc of contact 33 cos phi into cos 20 degree that is 31 mm. Okay, आर ए इक्वल टू आर ए, कैपिटल आर ए, क्योंकि आपका जब नंबर ऑफ टीथ इज सेम तो इट इज इक्वल रेडियस ऑफ अडेंडम ऑफ ईच व्हील दैट इज पिनियन एंड व्हील. ओके, तो रेडियाई आपकी कैपिटल आर क्या होगी, कैपिटल आर इक्वल टू स्मॉल आर इक्वल टू एम टी अपॉन 2, that is m equal to 6, t equal to 40 upon 2, that it is 120 mm. And there is a formula of length of path of contact. इक्वल टू फॉर्मूला हो रहा क्या है, यही फॉर्मूला था। और लेंथ ऑफ पाथ ऑफ कांटेक्ट अभी कितने हमने निकाला, 31। दिस इज सेम, तो 2 इज कॉमन, आर इक्वल टू सेम ना, आर इक्वल टू स्मॉल आर इक्वल टू कैपिटल आर ए, गिवन है हमें। तो दिस इज 120, 20, 120 sin 20, it is 15.5 r a square minus 12715 minus 41। ओके, तो इस साइड को हम इस तरफ ले गए, 41 का स्क्वायर, इसका रूट भी हमने हटा दिया, देन आर की यहाँ से वैल्यू हमारी जो आई है, जो वैल्यू आई उसका फिर हमने अंडर रूट ले लिया, 126.12 mm। सो addendum of the wheel, so addendum of the wheel equal to आर ए माइनस के आर, आर ए हमारा है 126.12 and this is 120, that is 6.12 mm, that is addendum। okay, it is answer। okay, this question is depend on the length of path of contact। okay, note down the question का सॉल्यूशन नोट कर लीजिए। and in our next class we will discuss the interference of involute gears, क्योंकि हमें पता है इंटरफेरेंस हमारा साइक्लोइडल में तो नहीं होता है, इन्वॉल्यूट में होता है। तो हम इन्वॉल्यूट में इंटरफेरेंस पढ़ेंगे और टू अवॉइड कैसे हम इस इंटरफेरेंस को अवॉइड कर सकते हैं। तो कैसे कर सकते हैं, मिनिमम नंबर ऑफ टीथ के थ्रू हम इंटरफेरेंस को अवॉइड कर सकते हैं, तो उसका हम डेरिवेशन पढ़ेंगे और देन उसमें न्यूमेरिकल भी पढ़ेंगे। लीजिए, दिस क्वेश्चन इज वेरी सिंपल। और इसी तरह हमारे क्वेश्चन जो आते हैं न्यूमेरिकल हमारे एग्जाम में जो आते हैं वो इसी तरह बेस्ड आते हैं। ओके, एडेंडम वही है, हमने बात भी कही थी, पिच सर्किल से एडेंडम तक की डिस्टेंस। इट इज कॉल्ड अडेंडम. ओके, तो पिस सर्किल का रेडियस कितना है आर, अडेंडम सर्किल का रेडियस कितना है आर ए. तो वो हमने माइनस कर दिया तो हमारा अडेंडम हमको पता चल जाएगा. ओके. नेक्स्ट क्लास, we discuss the interference. Okay. Okay. uh, Thank you class.